Okay, class, today we're going to be learning about basic electronic circuits. We're going to learn how to wire a few different kinds of circuits and learn what a few different schematic symbols and circuits mean. So let's go to the first slide here, and you'll see there's a few different things. We've got some wires and some buttons, and we've got a battery, a light bulb, and a basic schematic that has a few symbols that we'll learn here in just a second. So the first thing we're going to do is we're going to take a battery, a bulb, and one wire, and we're going to see if we can figure out a way with just a single wire to connect this battery, light bulb, and wire to get the light bulb to light. So the reason that I wanted you guys to attempt to light a light bulb with a single battery and a single wire was to see if you guys could use a little bit of creativity to create a circuit that generally people use two wires to use. And this same challenge was given to recent graduates of MIT and Harvard, and some of them weren't able to do as well as you guys did. So we're going to watch that video and check out what they struggled with.
Graduates of Harvard and MIT. The Massachusetts Institute of Technology.
We are the premier engineering and science institution in the world.
Do you think you could light a bulb with a battery and wire? Do you think you could light a bulb with a battery and wire?
Yeah. Light a bulb with a battery and a wire. Maybe. Yes.
All right.
Definitely.
Do you think you can light a bulb with a battery and a wire?
Battery and wire? Well, yes, why not?
Okay.
Definitely.
Okay, can you do that?
The interesting part about the batteries and bulbs question is that people always predict that they can do it. Students say, of course I can do this.
Any hints I should have here?
Teachers say, of course my students can do this.
Ow! Do you know why that didn't work?
I have no idea.
Battery could be dead, the bulb could be bad, I'm hooking it up totally incorrectly. I'm not an electrical engineer, I'm a mechanical engineer. But if I had to guess, I would say it's operator error.
Okay.
I know it's possible, but I don't know how to do it.
It's only after failing that you begin to get upset with the question and think, well, maybe it's a trick question, maybe this has something to do with manipulating the wires, they couldn't hold all the wires together.
You don't have a current if you only have one wire, you need to complete a closed circuit.
But that's not the case.
Oh, well, if I do it with a little light bulb, I just do this. In which case the light just lights up.
It goes to the fundamental understanding of electricity. If one cannot light a light bulb with a battery and wire, then everything built upon those basic ideas has problems.
We've always assumed that if teachers teach, students will learn.
You can't assume that what's blatantly obvious to you and has always been blatantly obvious to you is going to be that way to somebody else, especially a kid. And that's where you have to stop, regroup, and say, wait a second, is this really as self-evident as you'd like to think it is?
Sometimes the simplest problems in science defy intuition, and the most basic technology is surprisingly difficult to grasp. Is it because we weren't taught? Or is it because of something deeper?
Doesn't matter like what touches
something about the way we think.
So after watching that video, you guys can see that there are different creative ways to complete a circuit and get a system to work that isn't always the obvious solution, and we're going to be using that creativity and your own ideas to do a few challenges today that we'll get into in just a second here. We understand kind of why this does and doesn't work in different situations, but I want to get a little bit to the technical reason as to why that's the case. If we look at this slide, we can see here that the reason it doesn't work is because of what's called an open circuit. In order for a circuit to have electricity flowing through it to power devices, there has to be a closed circuit. There has to be a connection that goes from the positive or negative end from a power source, and that connection has to go all the way to the other end of the power source without any sort of disconnect in the process. And that's why we see here in the next slide that this is how we did it, and that's how it works. You can see in this note here that sometimes we also add a switch to the system so that the light bulb isn't constantly getting powered. We have the option to turn it off and turn it on without having to disconnect the power. So let's just look really quickly at some of these common schematic symbols. If we go back to this first slide for just a second, we can see that there's this light bulb that has some wire going to the power source, which is these lines right here, and also going to a switch. And right now the switch is open, but if we close the switch and make that line come down here to the circle, then you can see that this would be a complete closed circuit. So some of the schematic symbols we see in here are in this slide. So the battery, or the power source, is this line with these dashes in the middle, and we have our light bulb, which is just a basic oval inside of a circle. Okay, so we'll use those in some of the assignments that we have today when we are drawing what we're doing with the actual physical wires, so that you can represent what you've done with the materials on paper. So this one doesn't have any wires, which are just these basic lines crossing over each other. So whenever a schematic has lines that are crossing over each other, there's a special way to represent whether or not those are connected. In this slide, we can see that if they're connected, then there's a dot in the middle, and if they're not connected, one line has an arch going over the other line, or the lines are crossing over each other without a dot that is at the point where they intersect. Okay, so here we have the schematic, the drawing of the circuit that we created by lighting the light bulb with the battery. It's very basic. Power source, some lines, and a light bulb. Okay? Okay, so now what we want to do is we're going to do the same thing, only we want to add a switch that is normally open in the middle of the circuit, and you can have more wires for this one. And when you finish with the circuit, you need to draw the circuit on your notebook. Okay, so now we're going to experiment a little bit with what happens in circuits when we add components in different configurations. So we can see in challenge number 3, I want you guys to hook 2 light bulbs up together, but the key to doing this one is they need to be connected one after another, and that's called series. I want to quickly show you a different slide that shows what they might be like if they're in a different circuit called parallel. So what we're looking at here is series, and this right here is parallel, and that's when both of the light bulbs are independently connected to the positive and negative sides of the power source. But we don't want that on this one. On this challenge, what you need to make sure you do is have the power source be connected to one light bulb, and the power coming from that light bulb go into the next light bulb, not directly from the power source, but from the first light bulb, and they go around. What do you guys think will happen? Do you guys think the brightness of the light bulbs will change? Do you think maybe they won't light up at all? And I want you guys to write down why you think that's the case, and then we'll come together as a class and we're going to discuss a little bit about why you think it will act a certain way. Great, so we've got, we figured out what happens when these 2 light bulbs are connected. This situation is very similar, as one student said, to Christmas lights, that when you string more than one Christmas light strand off of another, all of the lights get less bright because the power is being distributed to more than one component. So we can actually prove that this is how it works with this equation, I equals V over R, and that is current equals voltage over resistance. So when there's 2 light bulbs, there's more resistance in the circuit, therefore the lights get dimmer, and that's why that happens. So now let's move on to the next one. We're going to keep the 2 light bulbs, but now we're going to add a second power source in series as well. In series meaning not independently connected to each light bulb, but one connecting to the other, then to each light bulb from one to the other. Okay? So talk with your group, see what you think is going to happen, and then we'll discuss that together. Okay, great. So we saw something relatively similar to what we saw with the light bulbs. Two light bulbs connected to each other, one after the other, in series makes the light bulbs dimmer. The same, but opposite, because we're talking about power sources now. If two power sources are connected one to another in a series fashion, they are able to transfer more total voltage to the other two lights, and it brightens the light bulbs. Now, in another challenge here, I want to see if I put that one more towards the end, or if it's closer here to the beginning. Oh, it looks like I have it then. So we're going to come back in just a second to what actually happens when these two power sources are in parallel. And you'll see what that looks like in the schematic, and it'll make a little bit more sense for you to be able to build it on your own, because you'll get to see how the wires connect to the different power sources. So let's go ahead and move on to the next challenge. And that is, we have two light bulbs that are connected together. And the switch is closed right now. But the light bulbs are on opposite sides of the switch. So what do you guys think will happen? And we'll discuss it. Okay, great. So what did everybody notice? We noticed that the same thing happened as the previous one. If we open the switch, both of the light bulbs turn off. Why does that happen? Because when we open the switch, the circuit is closed. Both of the light bulbs are on the same circuit, so both of them turn off. It doesn't matter that one is closer to one end of the power source, because one of the light bulbs, we can see here, one of the light bulbs is closer to the positive end, and the other light bulb is closer to the negative end, but that doesn't matter. If any part of the connection is broken, both light bulbs will turn off. So, we also noticed that they had the same amount of brightness as the previous challenge. It didn't make a difference that they were on opposite sides of the switch, and the reason is because when the switch is closed, when the circuit is complete, then it doesn't matter what's really in between it, as long as the wires are all the same kind of material, the light bulbs will still light up the same amount. So as I just explained on this slide, you can see that these two circuits are the same circuit. The only difference is that the bulbs are on opposite sides of the switch, but that doesn't make a difference for overall how much power each light bulb is going to receive. So let's go ahead and move on to the next challenge. Now we're on to what happens if we have the two light bulbs, the two power receiving components in parallel, which we can see here means that each one is individually connected to the power source, because each one is connected to the positive source and each one is connected to the negative source. Neither light bulb is reliant on the other light bulb for power. So what do you guys think is going to happen? Okay, great. So what did we see? We saw that unlike the two light bulbs that were connected in series, one light bulb and then the next light bulb, these ones both had a greater brightness, and the reason for that is because power doesn't have to be slowed down through the first light bulb before it gets to the second light bulb. Each light bulb is getting its own power, so each light bulb can be brighter. Okay guys, you did great today with all the different challenges. All that's left are, it's one worksheet I'm going to pass out to you guys that has these two questions in it with about 7 different schematics, and all you need to do is just decide if the bulbs will light, what the brightness of them will be, which ones will be brighter or dimmer than the others, and in the next one you'll just decide if at some times one bulb will light while the others will not. Turn that in to me and we're done for the day. That's it. Thanks guys.